Everybody, welcome to the Oklahoma City Astronomy Club. I'm Chuck Rice. I'm the club president, and we're doing this remotely through YouTube this month. I have to give a strong, boisterous shout out to Danny McDonald, who's our video technician. I'm sitting at home like many of you are. I'm looking at my computer screen and I'm looking at YouTube here. There's about a 1 minute delay from when I say something. I'm Chuck Rice. You get it? I'm the club president, and we're doing this remotely through YouTube. Let me. So, if you have questions or anything during the presentation, go ahead and type them in the chat function in YouTube. But there might be a 30-second delay or 60-second delay until actually we see them and can get them answered. So we'll see if we can work out the mechanics of that and everything works out okay. Let's certainly hope so. I see a bunch of people are logged on. So I'm just going to ask right now, are we doing okay on the audio and the video? So on YouTube, you can put in chat or thumbs up. I can see Danny on the computer screen. Danny, do you want to give me a thumbs up if we're doing okay? Danny's giving me, oh yeah, that is a thumb. Good, thank you, Danny. So we have a great presentation from Kerry Magruder. He's pre-recorded the presentation and we'll show that. And then Kerry will come on at the end to answer any questions. I'm looking at the chat right now. I see a message from Tom Graham, who is a new member, so that's wonderful. So everybody say hi to Tom. Normally we will meet in Oklahoma, and hopefully in June we'll be able to do that. The plan for the June meeting is to have a social gathering of some sort, hopefully refreshments, cake, cookies, probably not ice cream, but iced tea and lemonade or whatever. We'll find out a way that we can do that safely, whether it's going to be inside the building or outside of the parking lot, like a little picnic or something. We'll have to figure it out. The good thing is that hopefully the weather will be really nice in June. It's usually a pretty good month for mild temperatures in Oklahoma. I have a list of notes here. So let's see. As far as announcements for the club, we don't have very much on the observing that's been going on. So please check out the discussion board at okcastroclub.com. And there you'll be able to find the discussion board for observing events, people that are going out to the observatory, other things that are in the news. A reminder from Mike Madden, our treasurer, that your membership dues need to be paid if you haven't paid them already. So please do that and support the club. We'll be sending out reminders to your email. So if you haven't received them, please check your email junk folder or spam folder and make sure that we can get those paid. Normally we would do this in person, but you can pay online through PayPal or just send a check. All of that information is there on the discussion board and on the registration, the dues information on the website. This week's newsletter, normally we would have a print newsletter from Danny. He decided to do a web page. I looked at it. I think it's super duper fantastic. So please give another shout out to Danny for being really great with the graphic design and website information. Take a look at all of that, all of the links. That's wonderful. And then there's a lot of great things going on at Cheddar Ranch. We have the 30-inch telescope, the 14-inch telescope, all that stuff. It's a great time to get out there. We also have a great number of things happening out at the OKCAC Star Party. The new building is underway. We are pouring the concrete. The building's been ordered for the new facilities, etc. One thing to remember is that the meeting, OKCAC Star Party, is in early September. And so about 30 days before the start in early August, we will have an idea, or we will know absolutely whether we're going to have the Star Party or not. So at that point, if we decide not to have the star party, then everybody has ample time to change their plans. And if you've already paid, you'll be able to get a refund. So don't worry about registration for OKCAC, worried about COVID-19, are we going to have it or not? There'll be plenty of time for everybody to change their plans and get refunds and so forth and things like that. So let's see. Okay, so I'm looking at the chat. Everything looks good. Dave Hunt's said the dues reminder went out May 6th. Awesome. Looks like we have about 32 people online now through YouTube. I think that's pretty good. This meeting is going to be posted and available later on. So if you want to see the presentation later, you can watch it later. Or if some of your friends didn't get to see it or they had technical problems logging in with their computer, that would be fine also. But I would like to just take a couple of minutes to remind everybody to check the discussion board about a couple of club members who have fallen in poor health. So one was Glenn Kilgore, former observing coordinator, long-standing, long-time member of the club. He unfortunately is left the hospital, which is good, but now he's in hospice care. So please keep him in your thoughts. And then we obviously mourn the recent passing of Mo Massey, an unexpected shock to me that I didn't realize, that when he was in that type of health situation. But yeah, I mean, I've always had good thoughts about Mo. It's been very friendly, have seen him out at the Cheddar Ranch Observatory and at the meetings. He's been very friendly and very welcoming, just a really nice guy to be around. Really gonna be missed. I was looking online at the discussion board, and there is a webpage at remembered.com. And that link, Robin Rhodes posted on the discussion board. And so if you go out there, it shows pictures of Mo, a lot of his interactions, postings from friends and families and hobbies and things like that. And so it was actually really nice to go see that and learn a lot about Mo. And I kind of feel bad that we didn't know that much more about Mo before then. So it's kind of like I wish everybody had one of these already. I guess that's called Facebook, but I don't have a good Facebook page also. Danny just reminded me that the remembered.com link is also in the newsletter. So please do that. I'm sure that, his friends and family and his wife, Sherry, and son, Douglas, will appreciate any thoughts that we can have, especially from the Astronomy Club. Looking outside, I'm at home. It's clear skies. There isn't very much wind, pleasant temperature. I think it's going to be a great night to go outside and look at the stars, and I think that's something Mo would want us to do. The full moon is going to be out there, so should be a nice evening. I don't know what time moon rise and moon sets tonight. I didn't look that up before the meeting. Okay. So if somebody could post that on the discussion board or on the chat in YouTube about the moon setting time tonight and so forth. So anyway, good times in May. It's graduation time for everybody. It's Mother's Day weekend, so happy Mother's Day to all the mothers that are out there. Hope everybody can have as pleasant of a weekend as they can. I mowed the grass on Wednesday, so now I don't spend the weekend mowing the grass, so that's good. Okay. Right. I'm going to look over to Danny, who's in Astronomy Club Production Central, and ask if there's anything that we need to talk about. We did the announcements about membership and OKCAC and the meeting in June and so forth. So, okay. So we'll get started in a little bit with the presentation. So a lot of people in the club know Kerry Magruder. He's a professor at the University of Oklahoma in the History of Science Department. He gives a great presentation about astronomy and ancient cultures and recent history and ancient history. And so it's really fascinating to see how these stories have evolved and emerged over the years and the eons, and how we continue to learn lessons from that information from those ancient cultures. And so today, he's going to tell us about how do you know the Earth is round, or how do you prove the Earth is round, which is very applicable to astronomy, but it also talks about a lot of the misconceptions and early cultures and civilizations and how we were able to overcome some of those misconceptions. And I think that plays a large part into astronomy and misconceptions about the sky and astronomy and what lies beyond our small place here on Earth in the middle of the Milky Way galaxy. So I think we're okay. We're going to keep our fingers crossed that everything is good. We're going to play the video, and then I guess we'll be back in, about 46 minutes. So a little bit before 8 o'clock. So if you have questions, I think the best way to do that is probably to send them through the chat. So Danny McDonald will be looking at the chat. Andy Fryover will be looking at the chat. So we'll do that, and then we'll have more information about the June meeting at the end of tonight, and that's about it. So, okay. All right, I think Danny, let's get the show on the road. Okay, thank you. Thumbs up from Danny. All right, bye-bye, everybody. See you at the end.
It's a joy to speak with you about the shape of the Earth and the flat Earth myth. Have you seen this woodcut before? This strikingly beautiful depiction of the flat Earth was colorized for a poster by Roberta Weir in 1970. Adam McLean sells his beautifully colorized version of the same woodcut on his website, the Alchemical Web Bookshop. A 1970s recording artist, Jimmy Spheris, used the woodcut as envelope art in this letter. The Department of Biochemistry at the University of Minnesota advertised their molecular biology programs with the illustration. They adapted the extracosmic portion to resemble the organelles and cytoplasm of the cell. Suzanne Rich changed the extracosmic portion of the woodcut into an image of a computer world to accompany an article on astronomical computing in an issue of Sky and Telescope. Stardate magazine featured a colorized version of the woodcut on a cover, described as a medieval woodcut colored by Tim Jones. J.D. Bernal, the great 20th century historian of science and scientist, used a version of the woodcut to illustrate his once best-selling survey of the history of science. The caption reads, "In medieval times, there was a return to the concept of a flat earth and a dogmatism about the crystalline celestial spheres, here epitomized in a woodcut showing the machinery responsible for their motion, discovered by an inquirer who has broken through the outer sphere of the stars." 16th century. But is this really a medieval woodcut? Its provenance is notoriously difficult to track down. Despite Bernal's widely copied caption, the illustration credits at the end of his book offer no traceable source for the woodcut. This colorized version adorns the jacket cover of The Discoverers, written by the former Librarian of Congress, Daniel Boorstin. The book attributes this version of the woodcut to a quote, early 16th century woodcut, end quote. So they did not know where the original for their image came from either. Another colorized version of the woodcut, courtesy of Science Graphics in Tucson, Arizona, was included in a NASA publication called Exobiology in Earth Orbit. It appears with the following interesting caption. Quote, "A famous early 20th century engraving, 1911, erroneously thought to be a 17th century woodcut of a medieval astronomer passing through the sphere of the stars to see the mechanisms of the Ptolemaic universe beyond. End quote. How intriguing! For the original woodcut is not medieval in origin after all. Yet the NASA caption, again, like so many others, gives no specific source. How did the NASA writers know that it originated in 1911 without specifying a source? How can one know when one has found the first occurrence of a woodcut? As it turns out, the woodcut first appeared in a book by Camille Flammarion. He was the Carl Sagan of the 19th century, if you will. Flammarion was an astronomer and a popular science writer who worked at the Paris Observatory. He and his brother published hundreds of popular science books, abundantly illustrated. The Flammarions employed artists to create the custom-made drawings that they needed. This is the work, The Unnamed Source of the Ubiquitous Woodcut, published in 1888 and held in the History of Science collections of the University of Oklahoma. Flammarion prepared the woodcut to propagandize for the flat earth myth. Thanks to books like Bernal's and Borston's, many people think it dates from the Middle Ages. But it's from here. Many people still do not know that most medieval people knew the earth was round, at least roughly spherical. They also knew roughly how large it was. The mistaken modern belief that medieval people thought the earth was flat is the real flat earth myth. But if this flat earth story we've all heard is false, then how did the ancient and medieval scholars know the spherical shape of the earth? And how could we be so wrong about them? Let's explore these questions and what significance they may have for us. How did they know the spherical shape of the earth? Knowledge that the earth is a globe goes back to the ancient Pythagoreans, for whom the sphere was the most beautiful shape, and what is beautiful, they reasoned, must be true. They also gave weight to an argument from analogy. The cosmos is a sphere, and if the earth is a miniature cosmos or microcosm, then why shouldn't the earth have the same shape as the cosmos? The Pythagoreans liked to draw correspondences between the cosmos as a macrocosm and the earth as a microcosm, both beautiful spheres. In other words, for the Pythagoreans, the universe is a sphere. All the stars are bright points of light stuck on the inside of this giant, transparent celestial sphere that rotates around the earth once a day. All the stars trace circles around the sky and come back to the same place every 24 hours. The sphere of fixed stars has a north pole, an axis, and an equator. Every night, stars rise in the east, move overhead, then set in the west. Every 24 hours, each star traces a circle at constant distance from the North Pole. Stars that rise on the celestial equator turn in a giant circle exactly between the North and South Poles. This means that all the stars in the northern sky appear to turn in circles around the North Pole, just as if the stars were fixed to a giant transparent sphere. This is how the Pythagoreans envisioned it, and it's how it looks to the unaided eye. Let's step outside. To find the Big Dipper, face north. 4 stars make a bowl, and 3 stars make its handle. The Big Dipper is part of the constellation Ursa Major, or Big Bear, and the handle is the bear's tail. These 2 stars, on the pouring side of the bowl, point to Polaris, the North Star. So imagine that we will go outside many times tonight and note where the Big Dipper moves to, hour by hour. How will the Big Dipper move? The Big Dipper turns around the North Pole once a day. Think of the Big Dipper as stuck on the inside of the giant turning celestial sphere. And then it becomes easy to tell time by the Big Dipper when you're outside at night. A line from the pointer stars of the Big Dipper moves like the hand of a clock, turning counterclockwise around the North Star. In 24 hours, the pointers will return to the orientation they have now. In 12 hours, they will line up on the opposite side of the North Star. In 6 hours, the pointer stars will make 1/4 turn, and so on. Keep your eye on the Big Dipper or Ursa Major, the Big Bear. Remember that any star goes all the way around the sky every 24 hours, like this. Then you can think it through. This turning of the stars suggests that the universe is one giant transparent sphere, and so by analogy, the Earth also would be spherical. But the microcosm-macrocosm analogy is not the only evidence for the shape of the Earth available from the stars. Circumpolar stars, like the Big Dipper, prove that the Earth is curved from north to south. How so? Well, imagine an observer at the equator. The North Pole will lie exactly on the northern horizon for that observer. But if that observer travels to the North Pole will appear to rise above the horizon, and circumpolar stars will appear, stars that move around the pole without ever setting beneath the horizon. In the same way, an observer traveling south of the equator will observe stars circling the south celestial pole. Let's take the Big Dipper again as an example. In Athens, north of the equator, the 4 stars in the bowl of the Big Dipper are circumpolar. They circle around the pole without ever dipping below the horizon, although the tip of the handle passes below the horizon. But if we travel north to Paris, the pole star rises higher in the sky and new stars become circumpolar. From Paris, even the handle is circumpolar. If you think about it, the change in which stars are circumpolar, never dipping below the horizon, as you travel northward, this proves that the Earth must be curved from north to south. So the changing number of stars that are circumpolar proves that the Earth is curved both northward and southward. So we've proved the first step, that the Earth is curved in one direction. Now we need to prove that the Earth is curved from east to west. The shape of the Earth from east to west is proven by the risings and settings of stars as they rotate around the Earth every 24 hours. Each night, stars rise in the east, move overhead, and set in the west. As we saw with the Big Dipper, any star now rising on the equator will return to this same point in 24 hours. In 12 hours, it will travel to the opposite side. Instead of rising on this horizon, it will be setting in the west. In 6 hours, the star will go halfway to the other horizon and be crossing a midline overhead. These observations lead us to an interesting discovery. Suppose that on a given night, we observe the moon to rise roughly opposite the sun. The moon rises higher in the east long after the sun sets below the western horizon. Let's suppose that at this moment shown here, the moon enters into the shadow of a lunar eclipse. But we have a friend who lives far away to our west. Our friend to the west will not see the moon rise until it is long after sunset here. To him, the moon will already be in eclipse as it rises. In other words, simultaneous events, the eclipse of the moon, occur at different hours in local time in different places upon the Earth. This proves the Earth must be curved from east to west. If we watch a lunar eclipse at 10 p.m. tonight, and our friend sees the very same eclipse at the same moment, then our friend will say the eclipse happened at a different hour, perhaps at 8 o'clock his time. Those observations prove that the Earth cannot be flat. For if the Earth were flat, Stars would rise and set at the same moment regardless of where we are on the Earth. But in reality, if we see a star rising on our horizon, our friend who has traveled far west of us will not see that star rise until later. This means that the surface of the Earth between us is curved from east to west. So we first saw that the changing of circumpolar stars proves the Earth is curved from north to south. Second, we saw that the different rising and setting times in different time zones prove the Earth is curved from east to west. And if the Earth is curved both north to south and east to west, then it must be a sphere. The curvature of the Earth can also explain why watchers from a tall tower can spy travelers by land before they can be seen from the gates of the city. Similarly, as a ship draws near to a harbor, the lookout at the top of the mast is the first to call out, "Land ho!" At that time, the hull of the ship is too far down in the water to see the shore. For reasons like all of these, Plato knew that the Earth is a sphere. In his dialogue called the Timaeus and elsewhere, Plato laid the foundation for early Greek astronomy, distinguishing between various celestial circles such as the equator and the path of the sun. Then Aristotle likewise taught that the Earth is a globe. Far from advocating a flat Earth, both Plato and Aristotle assumed the Earth is a sphere, as the Pythagoreans had argued before them. For Aristotle, the spherical Earth lies in the center of the universe. Surrounding the Earth are giant celestial spheres. They're labeled lunae for moon, Mercury, Venus, Solus for sun, Martis for Mars, Jovis for Jupiter, Saturni for Saturn. And then beyond Saturn is a sphere of the stars, and beyond that additional spheres for further motions. The large sphere containing the fixed stars just beyond Saturn, it rotates around the Earth every 24 hours, while the planets are carried around on their own individual spheres. Now, don't confuse the Earth in the middle of the universe with a flat Earth. The Aristotelian cosmos was centered upon the Earth, but the Earth was a globe. In Aristotle's day, the nature of lunar and solar eclipses was well understood. In a lunar eclipse, the sun, earth, and moon fall on a straight line with the earth in the middle. The sun casts the earth's shadow upon the moon. By the 4th century BC, continuous lunar eclipse observations from Babylon went back several centuries. In every lunar eclipse, to observers located anywhere north or south or in different locations east and west, the Earth's shadow on the moon always appears curved. This fact was known to Aristotle. If the Earth were flat or any shape other than a globe, at least some of those eclipse shadows would be straight or angular. So the fact that it's always curved tells us that the edge of the Earth is always curved, no matter how the Earth's shadow is oriented and cast onto the moon, from any angle as seen from north, south, east, or west. Therefore, the Earth must be a three-dimensional globe. We see its silhouette on the face of the moon. Lunar eclipses prove that the far side of the Earth is curved. It is not necessary to circumnavigate the globe to behold with our own eyes that the Earth is a sphere. Just watch a lunar eclipse. Aristotle took another argument for the sphericity of the Earth, not from astronomy, but from physics. For Aristotle, all things strive toward their natural place, and the natural place of Earth, or earthy substances, is the center of the universe. Earthy things are always striving to reach the center. This is Aristotle's theory of gravity, why things fall straight down to the center. So Earth, if it falls to the center from all sides, then it the Earth as a body must be spherical. Aristotle's physics of natural motion proves that the Earth must be a globe. Yet surprisingly, modern writers sometimes do not understand this basic fact about Aristotle's ideas. The great physicist George Gamow, a founder of Big Bang cosmology, wrote, quote, "In the days when civilized men believed the world was flat, they had no reason to think about gravity. There was up and there was down. All material things tended naturally to move downward, and no one thought to ask why. The notion of absolute up and down directions persisted into the Middle Ages, when it was still invoked to prove that the earth cannot be round." End quote. Now, Gamow should have known better, and so should the reviewers and editors of Scientific American. In reality, Aristotle's theory of gravity contradicts a flat earth. Anyone who accepted Aristotle's theory of natural motion with its absolute up and down directions was logically compelled to assert that the earth must be round. So did this knowledge of the sphericity of the earth last? The answer is a resounding yes. Once Plato and Aristotle agreed that the earth is a sphere, few Western Europeans found reason to disagree. Now, it is true that if you look hard, you can find a few who denied it. A few Latin writers made a point of disputing the shape of the earth, but they did so because they were skeptics and they wanted to make a philosophical point. If something as widely accepted as the sphericity of the earth might turn out to be uncertain, then all knowledge about anything could be suspect. Some of these skeptics were Epicureans, and a few were atomists like Lucretius, who denied Aristotle's arguments from natural place and expected to find randomly shaped bodies scattered around the universe. One flat earther was the theologian Lactantius, who just on principle rejected everything Greek. Lactantius was not influential in the early church and was even declared a heretic. Later on, a millennium later in the Renaissance, he became more widely known for his writing style, which was admired by humanist scholars. But no one ever took him seriously on the shape of the earth. Another flat earther was Cosmas Indicopleustes, a Greek writer from the 6th century. Cosmas thought the universe was a huge rectangular vault above a flat earth lying on its floor. But Cosmas was neither typical nor influential. He was refuted by contemporaries like John Philoponus. His work survives in only 3 manuscripts, and his book wasn't even translated into Latin until the 18th century, more than a millennium later. He had zero influence on Latin Europe. He was actually copying ideas of the cosmos from India in the Sanskrit tradition, because he lived to the east. Despite a very minuscule number of doubters, the spherical earth was upheld without significant debate. About 150 AD, Claudius Ptolemy, shown here, wrote the standard work of late ancient and medieval astronomy, usually known from its Arabic title, Almagest, which means the greatest. In Book 1, Chapter 3, he listed the arguments for the sphericity of the earth, terra sit spherica, that the earth is a sphere. These arguments had persuaded earlier Greeks, including Plato and Aristotle, and Ptolemy presented them here. Ptolemy's arguments were, of course, never forgotten nor seriously contested. Even Latin writers working in non-mathematical traditions, like Pliny and his natural history, they also knew the earth was spherical. Similarly, Cicero described the spherical earth. Humans, he wrote, were created with the understanding that they were to look after that sphere called earth, which you see in the middle of the temple of the universe. End quote. The Church Fathers knew the earth was round and did not teach otherwise. Augustine makes a good example because in his commentary on Genesis, he made clear that the earth is a globe. Yet Augustine is sometimes cited as denying the existence of the antipodes. Now, the antipodes refer to the other side of the earth going south. Does this mean that he thought people in the southern part of the earth would fall off? Not at all. Like many geographers of the day, Augustine divided the earth into habitable regions separated by an uninhabitable zone at the equator that was too hot to travel across, they believed. Therefore, if people do live in the antipodes, meaning the southern hemisphere, then they're not part of the history recorded in the Bible. And in his book, The City of God, that history and the unity of the human race were what mattered to him. Augustine did not say that the antipodes do not exist. Rather, he just conceded that there is no way for descendants of Adam to get there from here. So it was with well-known writers from Pliny in the 1st century BC to Beda and Marcianus Capella to Macrobius and Augustine around 400 AD. Now, these are not obscure authors like Lactantius, and they all assumed the sphericity of the earth. Don't you find it odd, then, that medievals are now said to have believed in a flat earth? If we look to the later Middle Ages, there is still unanimity on the earth as a globe. When Aquinas wrote his Summa, the greatest theological work of the Middle Ages, at the very beginning he took for granted that readers knew the earth is round. That's the example he used when he wanted to show that fields of science are distinguished by their methods rather than their subject matter. Quote, "Sciences are distinguished by the different methods they use. For the astronomer and the physicist both may prove the same conclusion, that the earth, for instance, is round. The astronomer proves it by means of mathematics, but the physicist proves it by the nature of matter." End quote. Thomas Aquinas meant that astronomy can prove the earth is round from astronomical evidence, like lunar eclipses or changing circumpolar stars. On the other hand, physicists can prove that the earth is round from their own kind of evidence, the principle of gravity. Nor was knowledge of the earth as a globe confined to scholars in universities. A round earth was assumed in popular literature, as well as in the works of major authors like Chaucer or Dante. For example, when Dante described his travels down through the very center of the earth, he passed the center of gravity at Satan's belly button and began climbing upward to reach the other side. Even non-university people who read Dante knew the earth as a globe. Knowledge of the sphericity of the earth in the Middle Ages reached beyond the educated elite to the emerging mercantile class, and it permeated aspects of popular culture such as almanacs, feudal ceremonies, sermon illustrations, and cathedral iconography. For example, a globe with a cross on top symbolized the divine right of kings to rule Christendom, the whole earth. The cross stands for the authority of the king, and the globe stands for the realms around the globe given kings to rule. So whether in cathedral sculpture, paintings, tapestries, scepters, or other feudal depictions, this symbol of Christendom proclaimed the sphericity of the earth for all to see, including illiterate peasants. So knowledge of the shape of the earth was widespread in the Middle Ages. People took it for granted, but Nicola Rem delighted in proposing paradoxes that would test whether they had really thought through the consequences of a spherical earth. By all accounts, one of the greatest scientists of the 14th century, one of my favorites, Rem is most often remembered for his development of a graphical representation of Galileo's law of free fall. Of course, Galileo came 3 centuries later. Rem contributed to many other areas of inquiry as well. His book, The Book of the Heavens and the Earth, written in medieval French rather than in Latin, so it could be more widely read, that book captures something of his whimsical love of paradoxes. This was characteristic of Arem and many other 14th century scientists. Nor was Arem oppressed because of his scientific theories. He wrote openly in the vernacular to reach a broader readership. And to show his appreciation for this book, Charles V, the King of France, made Arem a bishop. Well, remember how Dante placed Satan at the center of the earth? Here's a thought experiment for you. Was Satan standing right side up or upside down? Arem answered both, because he would be weightless in zero gravity. Quote, assuming that the earth were perforated or pierced and that a man were at the center standing straight with his head in one direction from the center and his feet on the other, I say that such a man would have his head but also his feet on top or upwards, and he would be no more in a lying than in a standing position, nor facing downward more than upward. He would be weightless. Posing another paradox, Arem asked, if you build a tall tower so that each side goes straight up with a plumb line, will it be the same width at the top as at the base? Then he answered, if each side goes straight up, measuring by a plumb line, the top will be wider than the base, if it's tall enough. Each side makes a line that, if extended, would run through the center of the earth. Therefore, the lines must diverge as they go away from the center. It's logical. It's not realistic. It's a paradox. Carpenters can ignore this, of course. Do you know why water spilled on a table doesn't run off the side? Now, we would say hydrogen bonding, at least if we've studied chemistry. But Arem thought it was because the earth is round. The legs of the table are like the sides of the tower. They must diverge as they rise higher above the earth. Therefore, the table top is wider than the base, and the middle of the table is closer than the edges of the table to the center of the earth. The water won't spread out to the edges because to do so, it would be flowing uphill. That's why a drop of water seems to pool in the middle. Well, even though we know Arem's theory here is wrong, it's still pretty clever, isn't it? Another paradox is, what's the best way to go from Rome to Paris? North over the Alps, or should one travel west around them? Arem answered that because the Earth is a sphere, the shortest line between 2 points on its surface is obviously a tunnel. Or Arem's favorite paradox. He considered this one so much fun that he wrote it in verse. To appreciate this, remember that Easter Sunday is the most important date in the church year, and Catholic churches wanted to celebrate Easter Mass according to the same rule. Wouldn't it be awful if priests in 2 different cities celebrated Easter on different days? Okay, let's imagine 3 priests in the same city, say Paris, several days before Easter. 1 priest remains in the city, 2 depart on separate journeys. These 2 travel at the same speed on a road that encircles the earth. One goes west and the other goes east. And at the end of their journeys, all 3 are reunited on the same day. The priest who travels west returns in 8 days and 8 nights. At the same rate of speed and in the same amount of time, the priest who travels east returns, but he counts 10 days and 10 nights. And the priest who stayed home counts 9 days and 9 nights. Therefore, Arem said, 8, 9, and 10 days are exactly identical. But there's more. The priest who traveled east celebrated Easter during the first part of his journey, but then the following day he arrived where people were still fasting in Lent, though they calculate the day of Easter in the same way. Therefore, Easter and the day before Easter are the same day. In other words, Arem foresaw the international dateline. As he exclaimed, quote, "Hallelujah, I tell you, this story contains nothing that is not pure and simple truth," end quote. Okay, Arem was pretty sharp, but there's probably one question some of you are itching to ask. What about Columbus? We're on the Santa Maria heading west across the Atlantic. It's 1492. Didn't Columbus set out to prove the earth is round? Didn't the churchmen in Spain argue that his ships would sail off the edge of the earth? But think about it. There's something dreadfully wrong with what we were all taught about Columbus. Why would Columbus have to argue that the earth is round at a time when people believed the physics of Aristotle and the astronomy of Ptolemy? When the works of theologians like Augustine and Aquinas, and of writers like Cicero and Dante, all assumed that the earth is round. But we've been told about Columbus so often that we tend to believe it no matter how little sense it makes. We should learn to ask better questions. For example, we might ask, if everyone really knew the earth is round, then why did Columbus have such a hard time getting support for his voyage? Columbus had new ideas, all right, and he deserves a lot of credit for thinking he could sail around the world. For back then, Europeans thought that the far side of the earth, where the Americas are now, was just a watery hemisphere without any dry land. The reasons are complicated, but the habitable land of the eastern hemisphere was regarded as a cork floating on the water. And given this view, if there were just one wide ocean, then it would be too far and too dangerous to cross. The sailors would starve, and the ships would fall apart for lack of repairs. That, not the flat earth, was the error made by those who declined to financially support Columbus's expedition. So if people at the time accepted this view, why was Columbus willing to risk the journey? Columbus believed the earth is much, much smaller than it actually is. If the earth were as small as Columbus thought, then China would lie about where he found the New World. And that's why Columbus thought he had landed in China, and why the New World is named after Amerigo Vespucci, a geographer who recognized that the New World is not China. Columbus was lucky to find land in the Western Hemisphere right when he needed it. His skeptics were wrong about that, but they were right about the size of the earth. It's not nearly as small as Columbus thought it was. Eratosthenes, a librarian in ancient Alexandria, figured out the size of the earth before 200 BC. He was not the first or the last, but his estimate was the best, and it was never forgotten. From antiquity, it was known that the path of the sun, or ecliptic, is inclined to the equator by 23.5 degrees. From Alexandria at the mouth of the Nile, Eratosthenes heard that farther south on the Nile River, there was a town called Syene, where one day each year the sun would shine onto the bottom of a well. The well is that brown line going into the earth. In Syene at noon on the day of summer solstice, when the sun reaches its highest point in the sky, it reflected on the bottom of the well. So at that moment in Syene, the sun was directly overhead. But at the same moment, farther north in Alexandria, the sun cast a small shadow. Eratosthenes figured that by measuring the shadow in Alexandria, he could figure out how much of the curve of the earth separated Alexandria from Syene. By simple geometry, you can prove that the angle of the shadow from the top of the stick to the ground in Alexandria is the same as the angle from the center of the earth between Alexandria and Syene. The rays of the light from the sun are parallel because the sun is so far away. The line from the center of the earth to Syene goes straight out to the sun along one of the rays. But the line from the earth's center to Alexandria intersects the sunlight at Alexandria. There, the sunlight casts the shadow of the stick, and the stick is on the line from Alexandria to the earth's center. So the angle from Syene to the earth's center to Alexandria is an alternate interior angle to the angle of the stick's shadow. And alternate interior angles are the same. Eratosthenes measured the angle of the stick's shadow to be about 1/50th of a circle. Therefore, the distance from Alexandria to Syene must be about 1/50th of the distance around the Earth. Soldiers paced off that distance at 250,000 stadies, or stadium lengths. Multiply 250,000 stadium lengths by 50, and you have the circumference of the Earth. Eratosthenes' figure turns out to be almost exactly right. And now notice this measurement of the size of the Earth does not prove the Earth is round. From the start, it assumes the Earth is round. The shape of the Earth was not controversial. So why do so many people today think Columbus had to prove the Earth is round? This is the true flat Earth myth. The flat Earth myth is not an alleged medieval belief in a flat Earth, but the mistaken modern belief that medieval people thought the Earth is flat, when it is so easy, as we've seen, to show that they knew the Earth is round. Historian Jeffrey Burton Russell has shown that the answer lies in part with one of America's earliest writers. Washington Irving fooled a lot of readers when he dramatized the flat Earth myth. We all enjoy Irving's far-fetched tales, but his Life of Christopher Columbus presented itself as biography, not fiction. Unfortunately, it was about as factual as the Headless Horseman or Rip Van Winkle. Irving fabricated a tale of Columbus pleading his case before a council of inquisitors at a convent in Salamanca, Spain, who assailed him with citations from the Bible and the teachings of the church. Irving's account is nothing but misleading and mischievous nonsense. It should have been read only as a pleasant romance. Other French and American writers endorsed the flat Earth myth, and by the end of the 19th century it was being taught in universities. Andrew Dixon White, president of Cornell University, echoed Irving in his book, A History of the Warfare of Science with Theology in Christendom. White wrote, quote, "The warfare of Columbus the world knows well, how the Bishop of Ceuta worsted him in Portugal, how sundry wise men of Spain confronted him with the usual quotations from the Psalms, from St. Paul and from St. Augustine, how even after he was triumphant and after his voyage had greatly strengthened the theory of the Earth's sphericity, with which the theory of the antipodes was so closely connected, the Church by its highest authority solemnly stumbled and persisted in going astray." White continued, "In 1519, science gains a crushing victory. Magellan makes his famous voyage, yet even this does not end the war. Many conscientious men oppose the doctrine for 200 years longer." End quote. We owe many of our modern misconceptions about the flat Earth myth to White. For example, White propagated a mistranslation of Augustine to claim that Augustine affirmed a flat Earth. And actually, as we have seen, there were fewer than a dozen flat Earth writers before modern times, and none of them had any influence, nor were any accepted as authorities. The Catholic Church, for instance, always taught the sphericity of the Earth. Yet White took exceptions like Lactantius and Cosmas Indicoploistes as typical of the relationship between Christianity and science. White went looking for something, then found only what he wanted to find. White did exactly what he accused the medievals of doing, believing in whatever he wanted without regard for the weight of the evidence. And if we have believed in the flat Earth myth, how could we be so wrong? I wonder what else we believe about the past that's wrong. Maybe we don't know as much about the past as we think. What might we gain from studying history with the assumption that people in the past were actually just as bright and inventive as we are? How might we need to rethink our preconceptions of the present and of the relations between science and society and science and religion by studying the history of science? Oftentimes, we undervalue the past in order to convince ourselves of the superiority of the present. Back in the Middle Ages, scholars like Arem called themselves the Via Moderna, the modern way, in contrast to those who came before. But we do the same thing when we call their Via Moderna the Dark Ages. I think we would do much better to regard medieval scientists like Arem as living not in the Dark Ages, but in the Age of Illumination. But myths have a life of their own. Once the flat earth myth made it into our textbooks, it became impervious to evidence or correction. Although its source is unknown to most of those who use it, this woodcut is not a medieval woodcut at all and was only used to spread the flat earth myth. So pardon my asking, but who lives in a dark age now? This woodcut has proven to be an extremely durable piece of visual rhetoric. In the NASA publication, I think the theme of the image was transformed. It referred not to a flat earth, but to a common quest of discovery and exploration, the challenge of boldly going where no one has gone before. This seems to be the rhetorically durable appeal. It's what makes the woodcut so attractive to those who have reprinted or adapted it so frequently. It's definitely what I had in mind when I created the logo for the OBU Planetarium back in the 1990s while serving as planetarium director. It was because of this quest theme of breaking through the cosmic spheres to view the unknown beyond that Bob Nemiroff, editor of NASA's Astronomy Picture of the Day, created this half-colorized version to mark January 1st, 2000 as the onset of the new millennium. Now, although Flammarion intended to propagate the flat earth myth, he has ironically bequeathed to us an icon of cosmic quest, a search for truth. That figure is curious, determined to discover something new. He actually reminds me of Nicole Arem, and I hope Arem would think he resembles you and me too. And if we could bring him back to life, here's what he might say to us about our culture's flat earth myth. In the words of historian Jeffrey Burton Russell, quote, "The search for truth is long and laborious and easily set aside. And since the present is transformed day by day, minute by minute, second by second into the past, while the future is unknown and unknowable, we are left on the dark sea without stars, without compass or astrolabe, more unsure of our position and our goal than any of Columbus's sailors. The terror of meaninglessness, of falling off the edge of knowledge, is greater than the imagined fear of falling off the edge of the earth. And so we prefer to believe a familiar error than to search unceasingly the darkness." End quote. To take up that quest for truth, let us set aside the flat earth myth, no matter how disorienting or disconcerting we feel upon parting with such a familiar error. As we search for truth, we need not fear falling off the edge of the earth. Thank you. Now, my daughter, Susanna Magruder, colorized this version of the woodcut and has made it available. You can download it and make a print of it or put it on a coffee mug or a t-shirt. Search my personal blog, carriesloft.com, for Shape of the Earth, and you'll find it. The same post offers a PDF of the script for this presentation if you want to go back and refer to it more carefully. Thank you so much.
Enjoyed that conversation. I'm looking at YouTube and there's a couple of questions here. Kerry Magruder is with us and can answer a few questions also. Just remember there might be a bit of a delay or a lag time. So because there's already a couple of questions, we can start with those, and then by the time you get your question posted, we'll be answering someone else's, and hopefully there won't be too much of a delay. So Kerry, did you see the question from John?
I sure did. Hi, John. John asked, I wonder why there's been a resurgence of flat earth believers in recent years. The internet, social media, fake news. Yes, all the reasons that one might summon to explain the distrust of expertise and the prevalence and rapid spread of disinformation and fake news. All of that is certainly the chief explanation for fake news. Throw in the celebrity endorsement of some basketball players and other well-known celebrities, and you get the ingredients of a popular revolt against expertise. But it's all founded on a mistaken understanding that began at the end of the 19th century, in the heels of John Dixon White and other writers. Some traditionalists thought, okay, they thought the earth was flat in ancient times, so maybe that really is the case it is, and maybe people in the modern era are mistaken. So a society called the Zetetic Society was founded. And I'm so pleased that I was able, for the History of Science collections at OU, to purchase a copy of their journal. So you can come down to Norman and read it if you want. But it was published in the waning years of the 19th century, and it was a protest against modernity, as if we could go back to the good old days by believing in a flat earth. But the way that the belief in the flat earth has gone through many twists and turns is a 20th century story. It's incredibly fascinating as a tale of popular culture, and now, of course, of a populist revolt against expertise. But it has nothing to do with what actually happened in pre-modern times. I think we have a prejudice that because they didn't have computers and iPhones, in the past, they weren't as smart as we are. There's a chronological snobbery because they were so far away in the past, and a cultural snobbery. They were those Middle Easterners and whoever. And so we're surprised at the evidence presented in the beginning of the talk that actually they were really creative people, and in some ways far more resourceful than we are, despite all of our advantages. So thank you for that question. I'm looking over in the comments. Are there others?
I don't see any other questions that popped up. Did you see any, Danny? I don't see any. But I think that's a real good summary. I was talking to Kerry earlier that this makes me think about in anthropology, some of the cultural snobbery of, in England, they had the Piltdown man where they thought, oh, modern man emerged in England. Therefore, the English must be the cradle of civilization. And the same with whether it was in, France or Germany or even in the, North America. The oldest cave painting is in France. That's therefore modern man emerged in France. And I think, unfortunately, some of those lessons carry forth throughout her history and don't get learned very well. So.
Yes, I believe that's one of the benefits we gain from looking at stories from the past, is that we stand in a long tradition and we stand in a position of humility. We have, like Jeffrey Burton Russell wrote in the quotation at the end of the talk, it's hard to face the darkness, that to have enough courage to follow evidence and to research something carefully so that we can come up with the answers. It takes the same courage as we imagine the sailors had to be able to sail toward the edge of the earth and not fear falling off.
And I think a good way to follow up is with all this COVID-19 and social distancing and places are shut down. There's a lot of collections at the History of Science that are online, thanks to your efforts. And I think, this is a great lesson to be learned, that you can still do a lot of this research and information due to the online resources provided by you and the university. So thank you for that.
Well, thanks. And kudos to everyone in the Astronomy Club, and especially Chuck, to you and Danny for not canceling this meeting, but putting it on virtually. I'm really impressed. And I'm inspired by what you do to go out to plan this weekend. If I can't go out for dinner at, is it Hideaway that you normally,
Yeah.
then maybe I just need to get some popcorn here at home and put up The Rise of Skywalker or some suitable movie
Yeah.
to celebrate. So
Well, hopefully we can get together in June. So that's,
yes, that's right. Let's see. Eileen has commented it was that flat Earth woodcut was also used for the Star Party shirts and sweatshirts for the Texas Star Party and sold at the McDonald Observatory for many years. Yeah, it's such a wonderfully appealing woodcut. So there is a link that maybe we can provide in the discussion boards on the OKCAC's website, where you can all find the colorized version shown at the end of the show, because my daughter colorized that and has released that, so you're free to use it.
wow.
Copyright infringement. If you want to order a mug online or a print, then you're welcome to do so.
How large is the actual woodcut?
Oh, that's a great question. The book is large. It's a two-handed book, what we call in the trade a quarto. And there was a brief photograph of the majority of the page. I would guess that it's about 3 by 4 inches, something like that.
Okay.
It takes up less than half of the page. By the way, here is an example of a mug with that
Wow.
on it. I taught an online class this spring, and the members of the class decided, oh, we love that woodcut so much. Let's get a mug for everybody. So, and and this one came from Zazzle, and it's they sell mugs in 2 sizes. This is the large size. So if you want to put it on a mug or a note card or a T-shirt, whatever you want to do with it.
Okay. So I think that'll wrap things up. Just to remember, I would like to applaud Kerry. I know the audience can't applaud, but I see a lot of comments on the discussion board through YouTube that this is working out well. Hopefully in June, if we're at the museum for the little social hour, maybe everybody can bring their lawn chair. We'll all just sit out in the parking lot in our lawn chairs and talk to each other and enjoy the evening. And the sun won't set till about 9 o'clock or 9:30. So let's all hope for good weather in June. Everybody stay safe and wash your hands, and stay away from the baseball and softball size hailstones. So we had to dodge those in Norman the other day. So it's always exciting times. Anyway, thank you, everybody, and we'll keep in touch through the message board, and I think that's about it. So, okay, I think we'll sign off, and we'll just say goodbye to Kerry, and thank you again, and hopefully we'll see everybody soon. All right, bye-bye.